Welcome back, everyone. In this video, I'm going to explain quadratic equations. So I'll explain what is meant by a quadratic equation and how to solve it. So a quadratic equation is simply an equation of this form, ax squared plus bx plus c, where a is not equal to 0. What about b and c? B and c are any real numbers. A cannot be equal to 0 because what characterizes a quadratic equation is that it is a second degree equation. So x squared must exist in the equation in order to call it quadratic. Here there is a question which pops up. We know that the term quad stands for 4. For example, when we say quadrilateral, this means I am talking about a polygon with 4 sides. So why do we call it quadratic here and there is no 4 in the expression? The answer is the following. The term quadratic comes from the Latin word quadratum, which means square. This is why we call it quadratic equation because of the term x squared. And by the way, we call x to the power of 2 x squared in algebra because it is the area of a square with side x. So that is regarding the terminology. Next, I will explain 4 methods of solving a quadratic equation. The first method is solving a quadratic equation using the square root principle, and this only works with a specific class of quadratic equations. The second method is to solve quadratic equations using factoring. The third method is to solve quadratic equation using completing squares. And the final method, which always works with any quadratic equation, is to solve such equations using the so-called quadratic formula. Regarding the square root principle, what does the square root principle mean? If x squared is equal to a, with a non-negative, then x is equal to plus or minus the square root of a. So in order to use this method, I must have either x squared equals to a number, which is greater or equal to 0, or in general, something squared is equal to a number. Otherwise, if you have a general quadratic equation, it doesn't work. So in order for this method to work, I must have either this format or this format. In part A, we have x squared is equal to 3, which implies that x is equal to plus or minus the square root of a, which is 3. That's it. In other words, I need to look for a number whose square is equal to 3, which is either minus root 3 or plus root 3. For part B, we do the same thing, however, before applying the formula, I must divide both sides by 3, which is the number multiplied by the squared factor, and this gives us half x plus 5 to the power of 2 is equal to 36 divided by 3, that is 12, and now we have something squared is equal to a positive number. We can apply the square root principle, and this gives us half x plus 5 is equal to plus or minus the square root of 12, which means I will end up with 2 different equations. The first is half x plus 5 is equal to minus root 12, and the second is half x plus 5 is equal to plus root 12, and I solve each equation separately. So the final answer is x is equal to negative 10 minus 4 root 3 for the first equation, and x is equal to negative 10 plus 4 root 3 for the second equation. Now let us see how to solve a quadratic equation using factoring. Obviously, we first have to factor. This method is based on the following property. It is called the zero factor property, which says that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. In other words, at least one of the factors must be equal to 0. Of course, when I say at least, you might have both a and b are zeros. So let's do an example. So x squared plus 7x is equal to 0. I factor, which gives us x multiplied by x plus 7 equal to 0. So either x is equal to 0, that's the first factor and the first solution, or x plus 7 is equal to 0, which means x is equal to negative 7, and that's the second solution. Now there is a common mistake here. I can only use this property if I have a 0 on the right side. If the right side is not equal to 0, I cannot apply this property. Well, it is called zero factor property. So in other words, let's say you have a times b is equal to 1, for example. It means that the product of two numbers is equal to 1. Does this necessarily mean that either a equals to 1 or b is equal to 1? Of course not, that's wrong. It only works if and only if the right side is 0. Let us proceed with part B. So we have x squared minus x is equal to 30. As I mentioned, we must always keep the right side equal to 0, which means we have to move the 30 to the other side, so it becomes x squared minus x minus 30 is equal to 0. And this is a trinomial. We factor it, and you can refer to a previous video where I explained factoring in details. So here we end up with either x minus 6 is equal to 0 or x plus 5 is equal to 0, which gives us either x is equal to 6 or x is equal to negative 5. Let's now see how to solve a quadratic equation using completing squares. From its name, it's obvious that we have to use the method of completing squares. For this example, we have 2x squared minus x minus 5. Step number 1, the leading coefficient must always be 1. If it is not 1, then I must divide the entire equation by the given leading coefficient, which means I must divide the entire equation by 2, which gives x squared minus half x minus 5 over 2 is equal to 0. Step number 2, I move the constant term to the right. The third step is the step of completing the squares. This has to be a squared and this has to be 2ab, which means that a is equal to x, so half x is equal to 2 times a times b, which means half x is equal to 2 times x times b, and this gives b is equal to 1 over 4. After finding b, we add b squared on both sides, so it has to be 1 over 4 squared, and I also add 1 over 4 squared to the other side, because I cannot only add on one side. I have to add the same value on both sides so that the equation does not change. We now can factor the right side, and that's a perfect square, so it is x minus 1 over 4 squared, and the right side becomes 5 over 2 plus 1 over 16. We find a common denominator, so we multiply by 8 up and down. So this becomes x minus 1 over 4 to the power of 2 is equal to 41 over 16. And at this point, we can use the square root principle. So it gives us x minus 1 over 4 is equal to plus or minus the square root of 41 over 16, which gives us two equations, and the answers are x is equal to 1 over 4 minus the square root of 41 over 4, or x is equal to 1/4 plus the square root of 41 over 4. We now arrive at the most general method of solving quadratic equations, which is using the quadratic formula. If ax squared plus bx plus c is equal to 0, of course, provided a is not equal to 0, then we use this formula, and this is called the quadratic formula. So all I have to do is plug in the values of b, a, and c, and you get the answers. Now, depending on the number underneath the square root, which we call the discriminant, and I will explain in a minute why it is called the discriminant. So depending on this number, we know what the roots are. So if b squared minus 4ac happens to be positive, this means we will end up with two distinct real roots. The first one is negative b minus the square root of b squared minus 4ac over 2a, and the other one is negative b plus the square root of b squared minus 4ac over 2a. If it happens that b squared minus 4ac is equal to 0, it is like saying x is equal to negative b plus or minus the square root of 0 over 2a, which is just negative b over 2a. Now, if this is the case, we say that we have a double root. What is meant by having a double root? I'm going to give an example. So if you have something like x minus 1 squared is equal to 0, we can say that x minus 1 times x minus 1 is equal to 0. So the first factor gives us 1, and the second factor gives us 1 as well. Well, I know that it's the same answer, but it shows up twice. When the answer shows up twice, we say that it's a double root or double zero. More generally, we say that the multiplicity of this root is 2. The multiplicity means the number of the times the answer shows up in the equation. So we can either say we have a double root, or we can say that we have a root of multiplicity 2. So we discussed the case where b squared minus 4ac is positive, equal to 0. So we still have the case where b squared minus 4ac is less than 0. So here there are no real roots. However, we have two complex roots, as I will show you in a minute. So as I mentioned before, using the quadratic formula is the most general case, and it works with all quadratic equations. Let's see part A, for example, as well as part B. It is not easy to factor such a trinomial. Neither the square root property works. Whenever I have something like that, I right away use the quadratic formula. So first of all, we specify A, B, and C. A is equal to 1, which is the coefficient of x squared. B is also equal to 1, which is the coefficient of x. And C is equal to -1, which is the constant term. All I have to do now is what? Is to apply the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And this gives us the following two answers. Similarly for part B, we first specify a, b, and c, but I have to make sure that the right side is 0, which means I have to move the -2 to the left side. So a is equal to 1, b is equal to -2 root 2, and c is equal to 2. And I apply the quadratic formula, which gives us the following, and that is equal to 2 square root of 2 plus or minus the square root of 0 over 2. And this is the second case where we have one double root, which is equal to 2 root 2 over 2, and we cancel the 2's, so the final answer is the square root of 2. Let's now do part C. So A is equal to 1, B is equal to -1, and C is equal to 10, and the answer is 1 plus or minus the square root of -39 over 2, which means we have no real roots for this equation. We only have two complex roots. How do I do that? We convert the -39 into 39i squared, and as I explained in the sets of numbers video, I is an imaginary number which is equal to the square root of -1, or equivalently, I squared is equal to -1. We then continue as usual, and the answers are x is equal to half minus I root 39 over 2, or x is equal to half plus I square root of 39 over 2. I still want to add two more things. First of all, I want to go back to b squared minus 4ac. This value is called the discriminant, and it's denoted by this letter, which is delta. And why is it called discriminant? Because it does not only give us the solution for the equation, it also discriminates the solution of the equation, or it distinguishes between the solutions. So it also tells us what the nature of the solution is. Do we have real roots, or double root, or complex roots? So this is why it is called discriminant. One last thing I want to add, I'm going to show you how we got the quadratic formula. It is nice to know how to use the formula, but it's nicer if we understand how we got the formula. And that's exactly what I'm going to show you now. I will go back to the general quadratic equation ax squared plus bx plus c is equal to 0, with a is not equal to 0, and I will apply completing squares. So as we mentioned before, the leading coefficient of x squared has to be 1, which means I have to divide the entire equation by a. So this becomes x squared plus b over ax plus c over a is equal to 0. I then move the c over a to the right side. Then I complete the squares, which means, as I explained before, the perfect square pops up. We now find a common denominator for this. So we end up with this expression. And as you can see, the discriminant pops up. Not only that, we now can use the square root property. So we get this expression. Now we move the b over 2a to the other side, and we take out the 4a squared, but we have to be careful that we have to put a in an absolute value, because we never know whether a is positive or negative. Now, based on the definition of the absolute value of a is either plus a if a is greater or equal to 0, or minus a if a is less than 0. So we'll have plus minus an expression over plus minus 2a. So the plus minus and the plus minus will also give me a plus minus in the end, which means the expression becomes like this, and we got the quadratic formula. That is everything regarding quadratic equation. I hope that you liked the video. If so, please subscribe to the channel and stay tuned for the upcoming videos.